Live from Utrecht, this is the fan Wirdum Sjorsnado.
That's right. Hello.
Sjors, welcome back.
Thank you.
You confirmed your status as Bitcoin Core elite developer this week.
Absolutely. Thanks to me, there has never been a more amazing way to send Bitcoin. This is absolutely groundbreaking.
It changed everything.
It changed nothing.
Okay, to be clear, this is not what the episode's going to be about. The episode's going to be about Libsec256k1 library.
That's right.
But I want to know about this game-changing technology that you just built and implemented. What is it? What did it do?
Okay, so
how did it change the world, Sjors?
So there are many ways to send Bitcoin, but one of them is you download the Bitcoin Core software, and then it gives you a really nice graphical interface. You click a bunch of buttons, and poof.
So good. So far, so good?
So far, so good, but there's also a command line way to do it, and especially if you need to do anything advanced, like using it with a hardware wallet, you'll have to use the command line. And it turns out the command line doesn't do exactly what I wanted to do, and so then you just make a pull request to change it.
What did you want to do exactly that it didn't do?
Well, in this case, originally, I wanted to add PSBT support to
partially signed Bitcoin transactions.
Exactly, which we discussed in the first episode. I wanted to add that to the standard way of sending. But the problem is this command line stuff is used by a lot of automated systems. So a lot of Bitcoin exchanges, they might be running Bitcoin Core, and they might be relying, or Bitcoin ATMs, they might be relying on these methods, which means if you change them, you have to be very, very careful not to suddenly break like a million Bitcoin ATMs, right? So any change to the existing method will run into that type of problem. You can usually add stuff, but then it becomes super ugly because you just add another argument, and so it just becomes tedious to use. So ultimately, I decided to just create a new send method. So now there's like 5 different ways to send from the command line.
Right.
But there was a couple that were really designed from the beginning just to send coins to somebody else, and there was a couple designed for PSBT specifically, but those are very inconvenient to use if you just want to send something and click OK on a hardware device.
Right.
So this one is future-proof. It should be able to send coins very quickly, but if you want to then expand Bitcoin Core to work with hardware wallets, it's like a one-line change so that it also works for that, which is kind of why I built it. So it was a prerequisite of one of the many, many, many prerequisites to having easy-to-use hardware wallet support.
Right. Yeah, you've done a bunch of work on hardware wallet integration for Bitcoin Core, haven't you?
A little bit, yeah. I think the bulk is still Andrew Chow. He's been completely rewritten the wallet. I like to test this stuff and review it. But I'm using the library, the HWI library that he wrote, which is basically just a collection of drivers from all the different hardware wallets. So all the different hardware wallets, they usually have some Python code, but that also supports all their shitcoins. And we basically just took the essential parts of the code with just Bitcoin support,
right,
and just shoved it into one little project that you can download.
Right. So yeah, and the ultimate send RPG, what was it called?
RPC? Yeah, the ultimate send RPC was the name. I think it's going to be marked experimental because there'll probably be plenty of bike shedding of what the exact interface should look like.
Right, but it's a small step towards hardware wallet integration.
It's one of 100 small steps. Yes.
Great, thank you, Sjors.
Yeah, I was a bit surprised that it got merged as quickly as it did. So
should we be concerned? Should we be worried?
No.
Okay. We're gonna discuss Libsec such a long name.
256k1.
Yeah, thank you. Why are we going to discuss it? We are going to discuss it because BIP 340 support was merged into Libsec P256k1 this week.
What was merged?
Shut up.
Schnorr was added.
Yes. Okay. Yeah. So Schnorr. Exactly. Yeah. Thank you for actually making it clear for our listener. Oh, I misunderstood your question. Yeah, Schnorr was added.
Yes.
So Libsec P256k1 is a library.
That's right.
And we're gonna explain what this library actually is, or why it exists, or what it does. And the reason we're gonna explain that is because I actually didn't know that much about it. It's one of these things for me that I heard about and I kind of know what it is, but I never really got into it to any sort of serious extent. Okay, libraries, first of all. Let's start with libraries.
Let's talk about libraries.
There's a thing called software libraries.
Yes.
And I'll just let you explain what a software library is, first of all.
Well,
so for any programmer that's listening, this is probably going to be very, very noobish for you, but for people like me, this is actually kind of interesting.
The easiest way to describe what a library is it's a reusable piece of software. So, yeah, for example, OpenSSL is the library we'll talk about.
Mm-hmm.
It is a piece of software that lets you do all sorts of cryptographic operations, from creating random numbers to signing stuff with like every curve under the sun. But it's not an actual program. It doesn't really do anything by itself, but other programs can use a library to do whatever they want without having to rewrite that stuff.
Or I assume you can take a part of the library, not necessarily the whole library, but get a specific...
You take the entire library, but you use a subset of it.
Exactly, right? Yes.
Yeah.
So Bitcoin was at some point in the past relying on OpenSSL?
Yeah, until actually very recently, a few months ago.
Yeah.
But for less and less and less stuff. So in the beginning, OpenSSL was used for all the things.
Mm-hmm.
In particular, the reason it was needed is because Satoshi picked a cryptographic curve, the Segwit256k1 curve, because it was pretty, and OpenSSL had support for it. So he did not have to write all this cryptographic functionality, which of course you never want to do yourself. It's very dangerous to write your own cryptographic stuff.
Mm-hmm.
And this is also a reason why he didn't use Schnorr, because there was no library for it. There were other reasons, but this was a reason,
right?
For a practical reason.
So just to be clear, when you say Bitcoin Core or Satoshi used this library, the OpenSSL library, like how does a software program actually use a library?
You just Google on Stack Overflow how to use OpenSSL, and then you just look at the examples. And
Let me rephrase the question. Let me rephrase the question. Where is the library?
Oh, the library is included in the software package when you download it.
Right. So in this case,
the binary file contains some of the Bitcoin Core specific stuff, and then a whole bunch of libraries, and that's what makes it so big, or like 20 megabytes.
Right. So when you download Bitcoin Core, the software, Bitcoin Core 20 is the newest one, I guess.
Yep.
Then you actually download, well, in this case, not OpenSSL anymore, but for Bitcoin 19, you actually downloaded the whole OpenSSL library.
Yeah, that's correct. And OpenSSL,
and then it's hosted on your computer from that point on. It's just you have the library on your computer, on your own computer, right?
Now there is two ways to go about that. You can have a library sitting on your computer already, and then software can say, "Let me just see if I can find that library." And I'll use that. Mm-hmm. Then your download gets smaller. Mm-hmm. But the problem is that libraries change. And so you don't want to be surprised by what's on the computer, especially with cryptographic stuff.
Right.
And even if you include it in the download, you can be surprised by what happens to the library, because somebody else is maintaining that library. If you're not paying attention to what that other person is doing, they might break something very bad.
Right. So in the case of, let's stick to Bitcoin 19, Bitcoin Core 19.
In this case, maybe take an older one, because I think it was Bitcoin Core 0.8 or something. Or
let's take Bitcoin Core. I don't know where you're going with this, but let's take that one.
Yep.
So someone else is maintaining this library.
Yeah.
Bitcoin Core developers are maintaining Bitcoin.
Yep.
They write something in the code. They use some part of the library. You download the library from the Bitcoin Core code. A part of the library is used, and then the Bitcoin Core developers may not have noticed some change that happened in the library, and all of a sudden the stuff that they wanted Bitcoin Core to do isn't actually doing what they wanted Bitcoin Core to do, because the library wasn't doing what they thought it would do because someone else was maintaining the library. Is that a correct summary?
Yeah, that's right. And to clarify what specifically happened here,
you picked Bitcoin Core 8 because there was a specific example you wanted to go to.
Yeah, I might be wrong about the number, because Bitcoin Core 8 had a different problem. But sort of around that time, there was another bug in OpenSSL that I believe was unrelated to the problem that happened. But they basically had to upgrade OpenSSL because the old version was simply not safe. Mm-hmm. But unbeknownst to the core devs, there was another change in OpenSSL when they upgraded. And in particular, this was about when you see a signature, do you consider it valid or not? And the original version of OpenSSL was pretty relaxed. So it would accept signatures as valid, even if they did not meet the exact spec. Now, they wouldn't be signed by somebody else, so it wasn't about stealing funds. But it was just, you could be a little bit sloppy about, maybe you add a byte to the signature or maybe not, right? So the notation could be a bit sloppy. And the new version was very picky. Now, if you used Bitcoin software to create a transaction, that was not a problem. because any Bitcoin transaction was signed very strictly according to the protocol. But if you're now validating these transactions, if you use old software and you would see a sloppy version that was made with some other piece of software, the old software would be fine, the new software would say it's invalid. So all of a sudden you have an accidental soft fork.
Right, and that's what actually happens.
Well, yes. Well,
that's
it
the
never happened in the wild.
BIP66 one?
Right. So
Is that what we're talking about here?
Correct. BIP66 was introduced because people became aware of this problem. At least some of the developers became aware of this problem. So they knew there was like an accidental soft fork time bomb, basically, in the code. And so they proposed BIP66 as saying, oh, by the way, we should be more strict about these what these signatures look like. Without saying, oh, by the way, there's a bug in OpenSSL, so we better do this now.
Oh, it was like a secret bug fix of a problem with OpenSSL? I don't think I knew that. Okay.
Well, yeah. OpenSSL essentially improved itself by becoming more strict, but that made it a consensus change.
Right.
Because what's consensus code? It's also whatever your libraries are doing.
Right, yep.
So basically, OpenSSL introduced a soft fork, but without saying, oh, there's no deployment date in the OpenSSL update. It just randomly happened.
Right. So that's a great example of why a dependency, because that's the official term, is a problem.
Yep, exactly.
This is a good example of that. And there have been more problems with OpenSSL, I think.
I mean, OpenSSL is famous for vulnerabilities, and the main, I think, big reason behind that is that these libraries are used by everyone for decades, but they're only maintained by like one guy in Germany who doesn't get funded.
Right.
Just like curl, I think, is another famous example of that. It's like a library that downloads files. Curl, it's used everywhere. It's probably used in the space shuttle, but there's just one guy that maintains it, and nobody's helping.
Right.
And that's not good when the entire internet relies on it. And then in the case of OpenSSL, there have been plenty of bugs, and it's very easy to make mistakes with cryptographic code.
Yeah.
You forget, and it's written in C, so you forget a semicolon. Whoops.
Right.
Now you're skipping a line. So one of the bugs that was called Heartbleed.
Yeah, that was fairly recent, a couple years ago.
Yeah, a couple of years ago. I think it was a missing colon, or like it literally just a one character mistake.
Yeah.
And
it affected basically.
It allowed you to log into any computer on the internet.
Affected everything.
Yes. Yeah.
Right.
That's a sort of severity, and something like that in Bitcoin, of course, could mean, oh, now we have a problem. Everybody can just steal all the money. So eventually, well, at the same time, Peter Wuille was working on a library.
For our American and English listeners, that's Peter Wuille, or however they want to pronounce it.
Yeah, or SIPA or SIPA.
Peter Wuille, go on.
He was working on a library, so a piece of software, that was specifically designed to create and verify Bitcoin signatures. And his original motivation was just to do it faster than OpenSSL.
Okay. So it wasn't a security motivation; it was just a performance improvement motivation.
Exactly. He explains this in a podcast he did with Chain Code. So if you Google that, it might be in the show notes. Basically, he wanted to make it, I think, about 4 times faster, and he could try and modify the OpenSSL code itself, but apparently it's like such a nightmare to change any of that code. And also, the OpenSSL code is very generic. It has to support all different kinds of cryptography. So it's more difficult. If you want to change anything, you have to be very abstract in all the things you do, right? It's just like when you write a law. Like you can't just say John can't go to the supermarket. You have to say something like, well, anybody over the 20 centimeters in size cannot go to a supermarket. So it's very difficult to write these abstract documents. So he basically wrote it from scratch specifically for that curve, and it was added to Bitcoin Core, I think, pretty early, but just to verify signatures. And then later on also to create signatures. And that coincided with this security vulnerability. So it was a good, but I don't think it was a cause of it. It was sort of around the same time. It's like, okay, we've had this near miss, like we could have had a serious problem. Let's not use OpenSSL for that critical stuff anymore.
Yeah, and so then the goal was to get rid of that dependent was, I forgot the word.
To get rid of the dependency.
Dependency.
Exactly.
And write a whole new cryptographic software library for Bitcoin.
Right, it's just the curve.
Just a elliptic curve, just a thing that's used for signatures and...
Yeah, because there's other cryptographic code in the Bitcoin Core code base. For example, SHA-256 is in there and a few other curves. And I think those were originally also from OpenSSL. Mm-hmm. Those things are a little bit less scary. Like you can implement SHA-256 in a day if you're bored in any programming language.
Does it still use libraries for that though? or was that rewritten?
No,
or how?
so SHA-256, as far as I know, is directly in the code. So it's just copy pasted from somewhere and then improved.
Right, got it. Okay, so Libsec256. Am I saying that right?
Libsec256k1.
Thank you. That was to get rid. So it was meant as a performance improvement. Then it was pivoted to actually be a new library for Bitcoin, or at least sort of Bitcoin specific library to get rid of this dependency. You mentioned this before, but isn't that also a risk, like that rolling your own crypto? Or
Absolutely,
is that, yes.
absolutely. So the fact that this thing was this was reviewed by a lot of people, a lot of good cryptographers before adding it. And I think it was also compared against OpenSSL in terms of like using the same tests. But yeah, at some point you have to take that risk because the other one is like just waiting for OpenSSL to explode.
Plus, it was
But
Peter
it was
Ruyle, so can't really go wrong with that.
Well, you don't want to have proof of Ruyle. But a lot of very smart people looked at it. Probably the same people who would also look at OpenSSL. So that's good, but you don't want to make a habit of this. And in fact, they do constantly make very small tweaks to that library to make it a little bit faster. But it's you want to be very careful with that.
Right. Okay, so that's the library. Bitcoin has its own library now. Is this used by any other programs?
But keep in mind it's turtles all the way down, right? Because OpenSSL is also just written by people.
Sure.
So everything is an implementation at some point.
Sure.
But, okay. So your question?
I guess my first question would be, is this library used by anything other than Bitcoin?
Yes. So this library is, I just heard it on a podcast with Vitalik. It's also used by Ethereum. So, and a whole bunch of other cryptocurrencies. Basically any cryptocurrencies that uses the SECP256k1 elliptic curve, which is just a nice mathematical object.
Right. Mostly cryptocurrencies, though. Only cryptocurrencies. It's pretty cryptocurrency specific, at least.
Yeah, I'm not aware of any non-cryptocurrency project that uses it. It could, right? It's just a library that allows you to sign stuff, sign messages, and verify the signature on a message. So you could write a encrypted chat application that uses this curve if you wanted to. Sure. But I don't know. I guess the encrypted chat applications out there might have their own curve that they use for their thing. I don't know what Signal uses, but they could.
Yeah. Okay, so that's Libsec. I keep having to pronounce this.
Yeah, we just splice it in the audio later.
I'll just call it Libsec. Is there anything else that's called Libsec that would confuse people?
Libsec-P.
Libsec-P. Okay, so Libsec-P. Is that everything we need to know about Libsec-P?
I think so.
Yeah. Okay, so BIP 340 was merged, which is Schnorr.
Exactly.
This has been in development for a long time as well.
Yep.
I think for years, right?
Correct.
So this is also a new implementation of Schnorr. Is this the first time Schnorr has been included in any library? Because you just mentioned that
I don't know about any library, but at least at the time when Bitcoin was created, there was no library for Schnorr, or at least it wasn't in OpenSSL, which is like a widely tested library. You wouldn't just want to randomly download, oh, look, somebody implemented Schnorr.
Right.
But so what happened is, I think Satoshi was aware of Schnorr, but there was a patent on it. So, and there was no implementation. So it's kind of both of these things, because I think the patent was actually expired in 2008.
Yeah, I think it just lapsed or something. Yeah.
Yeah. But either way, you don't just want to write the stuff from scratch. And if you're trying to develop a world-changing thing, you don't want to then spend 3 years just implementing the cryptography, given how long it takes to really do this. So, but actually Schnorr is simpler. And I think we may have explained this in an earlier episode, but
you mean simpler than
ECDSA. So
yeah,
and because
which is the elliptic curve algorithm that Bitcoin currently uses,
right, and which the Libsec-P library implements.
Yes.
But the thing is, you have the same elliptic curve, but then in order to make a signature, you have to do slightly different calculations with it. So that also means that the change for Schnorr is not as complicated as, say, the initial version of Libsec-P was. The initial version of Libsec-P had to implement the curve, all the operations you can do on a curve, like addition and multiplication, and then implement the signature algorithm of ECDSA. But in order to do Schnorr, you just need to do the signature algorithm for Schnorr. You don't have to do all the math, the basic foundational math.
Right.
So it's not a huge change. It's not like adding a whole new curve to it. It would be much more difficult to add, say, a different elliptic curve or even a completely different kind of curve than it is to change just from ECDSA to Schnorr. It's a different way of signing. Okay. And in fact, a simpler way of signing.
So this was implemented again by Peter Wuille, I assume. Well, I know, or right? I'm not.
The spec was written by him. I think he also wrote most of the implementation, but there's a lot.
And there's others.
A lot of people on top of that.
Sure, and that was merged this week. So what does that mean exactly? Where does this get us?
Right. So what that means is there now is an updated version of this library, but nobody's using that library yet. And another change is that Bitcoin Core was changed, I think, a few days ago to include that new version of the library.
Right.
Just to include it, not to actually use it in any way.
So the first major release of Bitcoin Core, when you download that, you'll download the library that includes Schnorr.
Exactly, because the usual process is stuff gets merged into the master branch on GitHub, and every 6 months or so, we say, okay, let's stop at this point and release whatever is in there.
Mm-hmm.
And so next time that'll include the Schnorr code. Yeah, it'll be in there. It might not do anything. It might have a few tests that try it.
Right.
If you don't run the tests, you're not going to run it.
Yeah, the next Bitcoin Core release is not going to use Schnorr yet, is your prediction here. That's your bold prediction?
I would say it would be extremely reckless if it did. But there are
currencies
that use it, right? A certain Bcash coin uses Schnorr, I believe.
Oh, yeah, I think so.
But the actual spec for Schnorr was changed a little bit, so I don't know if they're going to change along with it or not. Not a huge change.
So anyways, it's going to be included in the library. Next time you download it, you're downloading this, but it doesn't actually do anything probably, or not anything too important.
Right.
But that would be a next step then. Like I wanna excite our audience, Sjors. We're getting somewhere, right?
Yeah, we
are. That's the plan, right?
So the idea here, of course, is to have Schnorr as part of Taproot. So the entire Taproot thing, there are already pull requests that describe what it's supposed to do that are, not completely finished, but pretty far along. Mm-hmm. So maybe they'll go in the next version, so not in the upcoming one, but the next one. What I would imagine happens is that it gets added not to mainnet, probably not even to testnet, but to this new thing called Signet, which is a whole new type of way to do testnet, which we can do another episode about. But basically, it'll go in some innocent way. So maybe there's just tests for it, tests for everything Taproot related, and then anybody who knows how to compile code can just flip a switch and try it on their own machine. But it won't be on mainnet, or probably not even on testnet. And then maybe next version, this stuff takes time. And then even though it's in there...
This isn't that exciting our audience.
Well, our audience...
Gotta pump it. Gotta pump this coin, Sjors.
I'm pumping load time preference. This stuff takes a long, long time. But basically, you add all the code in it, then you make... So everything is in there, but you don't activate it yet. And then the next time... you decide on activation mechanisms, and even those mechanisms might take a while.
That's a whole debate on its own, which we did an episode about, right?
Yes.
If I'm not misremembering. Okay, so that's what a library is. That's what a Libsec256k1 library specifically. Now you also know what Schnorr is. Well, actually, we didn't even get into what Schnorr is, but we get... Did we do that in the previous episode?
I can briefly
sure, go for it.
So
yeah,
it's simpler.
What's Schnorr actually, Sjors?
So what happened is there was this patent on this very simple system called Schnorr by a person called Schnorr, and it was very nice. It was a good way to make electronic signatures, but there was a patent on it. So people came up with a way to convolute the design, make it more complicated, such that it would no longer fall under the patent.
Right.
So when the lawyer said, okay, this looks obscure enough, so they were just adding numbers to it and subtracting things, just making it more complicated.
Yeah.
And then it didn't violate the patent, and so they shipped it.
Yeah.
But now we ended up with this horrible thing that is
convoluted mess.
Basically proof of lawyer, a convoluted mess. And now that the patent is expired, we just go right back to the original design, which is much better. And mainly it's better because you can add signatures much more easily, and adding signatures is very nice. Because
you can perform math on it.
Yeah, you could perform math on the original one, but you'd have to have you'd be able to publish papers just on the ability to add two numbers.
Right.
So.
Yeah, so for the layman listener, performing math on it just means you can do cool mathematical tricks, like add numbers to both the signature or both the public key and the private key, and then it still adds up and it still works, or you can add signatures or like all that kind of cool stuff.
Which in the end translates to more privacy and less block space usage. So it's all good.
Nice. And that's included in the Libsec. This is the last time I'm going to pronounce this. Libsec256k1 library. Yeah. And that means we're getting ready. we're getting ready to pump and to the bull's warming up. Sjors, is that right?
I'm sure it is.
Okay, then I think this was the episode, wasn't it?
Yep. Thank you for listening to the Wirdum Sjorsnado.
There you go.